Next question. If f maps R to R and g maps R to R are two functions such that f of x plus f double dash of x is equal to minus x into g of x into f dash of x, and g of x is greater than 0 for all x belonging to R, then the function f square of x plus f dash x whole square has option A, a maxima at x equal to 0, option B, a minima at x equal to 0, option C, a point of inflection at x equal to 0, and option D, none of this. It is given that f maps R to R and g maps R to R are two functions such that f of x plus f double dash of x is equal to minus x into g of x into f dash of x, and it is also given that g of x is greater than 0 for all x belonging to R. It is given that g of x is greater than 0 for all x belonging to R. Now, we need to talk about local maxima and minima of the function f square x plus f dash x whole square. We have to find local maxima or local minima, or if it is a point of inflection at x equal to 0 for the function, let us call it h of x equal to f square x plus f dash x whole square. So, let us differentiate this. H dash of x is equal to derivative of f square x 2 f of x into f dash of x plus derivative of f dash of x whole square 2 f dash of x into derivative of f dash of x, which is f double dash of x. From these two, if we take 2 f dash of x common, we are left with f of x plus f double dash of x. Now, we know that for all x, f of x plus f double dash of x is equal to minus x into g of x into f dash of x. So, even at x equal to 0, this equation holds good. So, f of 0 plus f double dash of 0 is equal to 0 into whatever is 0. So, f of 0 plus f double dash of 0 is 0, or h dash of 0 would be 0. H dash of 0 would be 0. So, once h dash of 0 is 0, either h dash of x has to be a local maxima or local minima or a point of inflection. So, let us see what h dash of 0 is. At h of 0, we have to investigate for either local maxima or local minima or a point of inflection. Now, for that, instead of going for second derivative, we can focus on the first derivative test. F of x plus f double dash of x, we can replace it by minus x into g of x into f dash of x. So, this quantity will become minus 2 into x, 2 from here, x from there, g of x into f dash of x into f dash of x, f dash of x whole square. Now, from first derivative test, we are investigating for local maxima or local minima at 0. Observe h dash of 0 minus and h dash of 0 plus, h dash of 0 minus and h dash of 0 plus. Based on that, we will be able to conclude if it is a maxima or a minima. Now, g of x is always positive. It is given that g of x is always positive. So, this is a positive number. F dash x whole square is always positive. F dash of x whole square is always positive, and minus 2x will be positive if x is negative and negative if x is positive. So, to the left side of 0, h dash of x is positive, and to the right side of 0, h dash of x is negative. Let us look at it again. G of x is given to be positive, f dash of x whole square is also positive. So, minus 2x will be positive when x is negative and negative when x is positive. So, h dash of 0 is positive whenever x is less than 0 and negative whenever x is greater than 0. So, whenever a positive slope is there, tangent equation would have acute inclination, and whenever there is negative slope, it would have obtuse inclination. So, the function has a local maxima at x equal to 0. So, for this function h of x, it has a local maxima at x equal to 0, it is option A. If f of x is equal to x square plus 2 root 2 cx plus b square and g of x is equal to minus x square minus 2 cx plus b square, such that minimum of f of x is greater than maximum of g of x, then the relation between b and c is option A, no real value of b and c, option B, c lies between 0 and b root 2, option C, mod c is less than mod b root 2, and option D, mod c is greater than mod b root 2. It is given that minimum value of f of x and g of x are two quadratics. F of x is equal to x square plus 2 root 2 cx plus b square, and g of x is equal to, this is also a quadratic, minus x square minus 2 cx plus b square. Now, it is given that minimum value of f of x is greater than maximum value of g of x. So, we need to find the condition on b and c such that minimum value of f of x is greater than maximum value of g of x. F of x is a quadratic with coefficient of x square positive. It will have minimum value when x is equal to minus b by 2a, and that value will come out to be minus d by 4a. A quadratic with coefficient of x square positive will have least value when x is minus b by 2a at the vertex, and when coefficient of x square is positive, it will have greatest value when x is equal to minus b by 2a. So, let us find greatest and least values of these functions. Another alternate way of finding greatest and least values of these functions is, you can see this as x square plus 2 root 2 cx. Look at the formula of a plus b whole square. A square plus 2 a b root 2 c. Let me add and subtract root 2 c whole square, which is 2 c square. So, 2 c square here makes it x plus root 2 c whole square. F of x can be written as x plus root 2 c whole square plus b square minus 2 c square. Now, a perfect square, least value of this would be 0. So, minimum value of f of x is b square minus 2 c square, that is when x is equal to minus root 2 c. Similarly, we can see the formula of a plus b whole square here, minus of x square plus 2 cx. Had there been a plus c square here, so let me add c square and subtract c square. This will become x plus c whole square. So, g of x is b square plus c square minus of x plus c whole square. From b square plus c square, you are subtracting a perfect square. So, g of x will be maximum when this perfect square is 0. So maximum value of g of x is b square plus c square. Now we want b square minus 2c square to be greater than b square plus c square, which is never possible. B square minus 2c square can never be greater than b square plus c square. B square plus c square is greater than b square, and b square minus 2c square is less than b square, and b square minus 2c square can never be greater than b square plus c square, or minus 2 can never be greater than 1. So for no value of b and c, this condition minimum of f of x greater than maximum of g of x is possible. So it's answer A. Next question, a function g of theta is equal to integral 0 to sin square theta f of x dx plus integral 0 to cos square theta f of x dx is defined in the interval minus pi by 2 to pi by 2, where f of x is an increasing function, then g theta is increasing in the interval option A minus pi by 2 to 0, option B minus pi by 2 to minus pi by 4, option C 0 to pi by 4, and option D minus pi by 4 to 0. G of theta is given as integral 0 to sin square theta f of x dx plus integral 0 to cos square theta f of x dx whenever x lies between minus pi by 2 to pi by 2. For all x belonging to minus pi by 2 to pi by 2, g of theta is given as integral 0 to sin square theta f of x dx plus integral 0 to cos square theta f of x dx. Now, g of theta, because it is obtained by integrating f of x, g of theta is continuous and differentiable function, and for a differentiable function to be strictly increasing, g dash theta should be greater than or equal to 0. So the question says f of x is an increasing function, f of x is an increasing function, and g of theta is increasing in which interval? So it is given that f is increasing, and we need to find the interval in which g is increasing. So let us observe g dash theta. We have to differentiate a definite integral. For that, let us use Newton-Leibniz theorem. Derivative of an integral is derivative of upper limit 2 sin theta cos theta, which is sin 2 theta, into functional value of the upper limit f of sin square theta minus derivative of lower limit is 0, 0 into whatever is 0, plus, let us differentiate this, derivative of upper limit 2 cos theta into derivative of cos theta is minus sin theta, minus 2 sin theta cos theta is sin 2 theta with a minus sign, and function value of the upper limit f of cos square theta. So g dash of theta is equal to sin 2 theta can be taken common, f of sin square theta minus f of cos square theta. So we need to see, for the function to be increasing, g to be increasing, g dash of theta has to be positive. G dash of theta has to be positive. So let us see in which of the intervals g dash of theta is positive. Option A, the interval is given to be minus pi by 2 to 0. Interval is given to be minus pi by 2 to 0, and in minus pi by 2 to 0, sin 2 theta is negative. Whenever theta belongs to minus pi by 2 to 0, 2 theta belongs to minus pi to 0, which is third and fourth quadrant, and in third and fourth quadrant sin is negative. Now f is an increasing function, so f of sin square theta will be greater than f of cos square theta if sin square theta is greater than cos square theta, and f of sin square theta will be less than f of cos square theta if sin square theta is less than cos square theta. So 0 to pi by 2 minus pi by 2 to 0, tell me whether sin square theta is greater or cos square theta is greater. It becomes difficult to say. from minus pi by 2 to minus pi by 4, cos square theta is greater, and from minus pi by 4 to 0, sin square theta will be smaller. So, partially it will be increasing function, in the other part of the interval it will be decreasing function. So, option A is not the right answer. Let us cut this minus pi by 2 to 0. Let us cut this discussion from minus pi by 2 to minus pi by 4, which is option B, and from minus pi by 4 to 0, which is option D. So, if one of the intervals we found it to be increasing, and in the other interval we found it to be decreasing. So, let us see in which of the intervals it is decreasing. From minus pi by 2 to minus pi by 4, 2 theta falls between minus pi and minus pi by 2, which is third quadrant, and sin 2 theta is negative. Sin square theta, magnitude of values of sin square theta will be more than the magnitude of values of cos square theta. Cos square theta values will be closer to 0 and sin square theta values will be closer to 1. So, sin square theta is greater than cos square theta, and because f is increasing function, f of sin square theta is greater than f of cos square theta. So, f of sin square theta minus f of cos square theta is positive. So, g dash theta is product of a negative number and a positive number, negative in the interval minus pi by 2 to minus pi by 4 and positive in the interval minus pi by 4 to 0. Positive in the interval minus pi by 2 to 0. So, g of theta is increasing in minus pi by 4 to 0, which is option D. Next question, f of x is equal to x by 1 plus x tan x for all x belonging to 0 to pi by 2 has option A exactly one point of maxima, option B has exactly one point of minima, option C f of x is increasing in 0 to pi by 2, option D none of this. So, we have to discuss maxima, minima, increasing, decreasing nature of the function f of x is equal to x by 1 plus x tan x in the interval 0 to pi by 2. In the interval 0 to pi by 2, 1 plus x tan x is positive, x is positive, tan x is positive, x plus tan x is positive plus 1, and x is differentiable, tan x is differentiable, x by 1 plus x tan x will also be a differentiable function. So, let us take help of application of derivatives to talk about monotonicity as well as maxima minima of this function. For that, we have to look at f dash of x. Instead, I can divide numerator and denominator by x, 1 by x plus tan x. This is a positive function, tan x is positive, 1 by x is positive, and f of x is reciprocal of a positive function. So, wherever 1 by x plus tan x is decreasing, f of x would be increasing. Wherever 1 by x plus tan x is increasing, f of x would be decreasing. Wherever this has a point of local maxima, f of x has a point of local minima. So, let us take the advantage of 1 by x plus tan x being positive in the interval 0 to pi by 2, and let us look at monotonicity and maxima minima of the function g of x is equal to 1 by x plus tan x. G dash of x would be minus 1 by x square plus secant square x, which can be written as, this is 1 by cos square x, take LCM, x square minus cos square x divided by x square cos square x, x square x minus cos square x divided by x square x cos square x. Now, let us see if g dash x is entirely positive or entirely negative. At 0, numerator is minus 1. So, this is a negative number, and at pi by 2, pi square by 4 minus 0, it is a positive number. So, partially it is negative and partially it is positive. So, g dash of x initially it is negative and finally it is positive. So, it can't be a strictly increasing function or strictly decreasing function. So f of x is not a strictly increasing function nor a strictly decreasing function. Let us look at the graphs of x square and cos square x. Cos square x from 0 to pi by 2 varies from 1 to 0, and x square is a parabola from between 0 to pi by 2 varies from 0 to pi square by 4. So, they intersect at a point, and they intersect exactly at one point. And before this point, x square is smaller than cos square x. Initially it is negative, g dash x is negative. After this point, g dash x is positive. So, there exists exactly one point where g dash of x is 0, and after that point g dash is positive. Before that point g dash is negative. So, for the function g, this is a point of local minima. So, for the function f, it will be a point of local maxima. So, f of x has exactly one point of local maxima, which is option A. Next question, the function f of x is equal to minimum of mod x and root over 1 minus x square when x lies between minus 1 to 1 possesses option A, local minimum at x equal to minus 1, option B, local maximum at x equal to 0, option C, global minimum at x equal to 1, and option D, global maximum at x equal to 1. Let us see, we have to discuss global maxima, minima and local maxima, minima for the function f of x is equal to minimum of mod x and root over 1 minus x square when x lies between minus 1 and 1, domain of the function is minus 1 to 1. So, to understand which of the two functions is minimum, let us plot the graph of mod x and root over 1 minus x square. Mod x we all know, it is a v. We are ranging this from x equal to minus 1 to x equal to plus 1. Understand the function y is equal to root over 1 minus x square. Y square is equal to 1 minus x square, or x square plus y square is equal to 1. Distance from origin is 1. This is equation of a circle. This is equation of a circle. So, y is equal to root over 1 minus x square is half part of a circle, the upper semicircle, with the diametric ends as the points minus 1 comma 0 and 1 comma 0. Now, we have to see which one of the two is minimum. The one which is below is minimum, and that will become f of x. So, the one which is above, we have to erase it. Up to this point, mod x is above. From this point, root over 1 minus x square is above. After this point, mod x is above. So, this is the graph of f of x, which is minimum of mod x and root over 1 minus x square. So, we can see a sure non-differentiability at this point, and there are global maxima. Local maxima we have at minus 1, 0 and 1. There is only one local minima, which is 0. Minus 1 and 1 we cannot say them local minima, because to the left and to the right there is no definition of the function, and these 2 points are local as well as global maximum. So, among the options, minus 1 is not a local minimum, so it is not option A. 0 is not a local maximum, it is a local minimum, so it is again not option B. Yes, global minimum is at x equal to 1, 0 and minus 1. So, option C is the right answer. Next question, if f of x is equal to a naught plus a1 x square plus a2 x power 4, so on up to an x power 2n be a polynomial where a naught is less than a1 is less than a2 is less than so on up to an, and all are positive, then f of x has option A, neither a maximum nor a minimum, option B, only one maximum, option C, only one minimum, option D, none of this. For the function f of x is equal to a naught plus a1 x square plus a2 x power 4 plus so on up to an x power 2n, where a0 is given to be less than a1 is given to be less than a2 is given to be less than an, and are all positive. So, a0, a1, a2 so on, they are all greater than 0. Then we need to discuss if f of x has a maxima or a minima, or if it is only one maximum, one minimum, or neither maximum minimum. So, we need to discuss maxima minima of the function f of x is equal to a0 plus a1 x power x square plus a2 x power 4 so on up to an x power 2n. This is a even function, even degree polynomial, differentiable. So, to talk about maxima minima, let us look at f dash of x. F dash of x would be differentiate a0 derivative is 0, a1 into derivative of x square is 2x, 2a1 into x plus 4a2 into x cube, derivative of x power 4 is 4x cube, plus next term would be a3 x power 6, derivative of x power 6 is 6x power 5 so on up to 2n an into x power 2n minus 1. So, in this you have all odd powers of x, we have all odd powers of x. Let us take that x common, x into 2a1 plus 4a2 x power 2 plus 6a3 x power 4 plus so on up to 2n an x power 2n minus 2. Now, here we have to see when f dash x can be 0. We need to investigate for maxima and minima, and maxima and minima for a differentiable function occurs at critical points where the derivative is 0. So, clearly when x is equal to 0, there is a critical point, f dash x is becoming 0. Let us see if there exists any other root for this equation. a1, a2, a3 so on up to an are all positive numbers. X square x power 4 so on up to x power 2n minus 2, even powers of x, so all positive numbers. So, sum of all positive numbers can never be 0. Sum of all positive numbers can never become 0. So, only point where f dash x is 0 is x is equal to 0. So, there is only one critical point, x is equal to 0. And let us see if this is a maxima or a minima. F dash of 0 minus to the left of 0, this number is positive, x is negative, x is slightly less than 0. So, f dash is also negative. So, we have a tangent with negative slope to the left of 0, and to the right of 0 x is positive, this number is positive. So, slope of tangent is positive. So, we have positive tangent to the right, negative slope tangent to the left. This is a point of minima. From first derivative test, we can say this is a point of minima. So, there is only one point of minimum, which is option C. Next question, the least value of f of x is equal to a square secant square x plus b square cosecant square x given ab is greater than or equal to 0 is option A plus b whole square, option B a plus b whole cube, option C 2 into a plus b whole square, option D none of these. We have to find the least value of f of x is equal to a square secant square x plus b square cosecant square x, and it is also given that AB is greater than or equal to 0. Now, secant square x, we can write it as tan square x plus 1. Cosecant square x, we can write it as cot square x plus 1. So, do not rush to differentiate whenever you are asked for maxima or minima. you can see secant square x as tan square x plus 1. So, a square tan square x plus a square. Cosecant square x as cot square x plus 1 plus b square cot square x plus b square. Now, you can see tan square x and cot square x are reciprocal of one another. Reciprocals of one another. Applying am greater than or equal to gm on these two numbers, we have a square tan square x plus b square cot square x divided by 2 will always be greater than or equal to root over this 2, we can take it to the other side, root over a into b, geometric mean of these two numbers. So, product of these two numbers is a square b square tan square x into cot square x, which is 1. So, a square tan square x plus b square cot square x by am gm inequality, we can say will always be greater than or equal to 2 root over a square b square, which is 2 mod ab, and mod ab as ab is given to be greater than or equal to 0 will be ab. As ab is given to be greater than or equal to 0, we can say a square tan square x plus b square cot square x will always be greater than or equal to 2ab. So, f of x will always be greater than or equal to a square plus b square plus 2ab, which is a plus b whole square. So, the least value of f of x is a plus b whole square, which is option A. Next question, f of x is equal to e power x minus e power minus x minus 2 sin x minus 2x cube by 3, then the least value of n for which d power n f of x by dx power n, nth derivative of f of x, yet x is equal to 0 is non-zero. Nth derivative of f of x at n equal to x equal to 0 is non-zero. Option A 4, option B 5, option C 7, option D 3. So, for the function f of x is equal to e power x minus e power minus x minus 2 sin x minus 2 by 3 x cube we need to find the least value of n such that d power n f by dx power n, nth derivative of f of x, yet x is equal to 0 is non-zero. Look at f of x, differentiate f dash of x, it is e power x plus e power minus x minus 2 cos x minus 2x square. At x equal to 0, this becomes 0, e power x is 1, 1 minus 2, 0, so it is 0. So, n is not 1. Let us again differentiate it, f double dash of x, derivative of e power x is e power x, derivative of e power minus x is minus e power minus x, derivative of cos x is minus sin x, and derivative of x square is 2x. So, at x equal to 0, 1 minus 1 it is 0, sin x is 0, 4x is 0. So, f double dash is also 0. Let us look at f triple dash of x, e power x plus e power minus x plus 2 cos x minus 4 at x equal to 0, this is 1 plus 2 minus 4, which is again 0. So, n is not 3. Let us look at n equal to 4. Differentiate e power x, it is e power x minus e power minus x minus 2 sin x, and derivative of constant is 0. At x equal to 0, 1 minus 0 is 0. So, n is again not 4. Let us check it with 5. E power x derivative is e power x plus e power minus x minus 2 cos x, again at x equal to 0, 1 plus 1 minus 2 is 0. So, let us look at n equal to 6. e power x minus e power minus x plus 2 sin x at x equal to 0. This is again 0. So, let us look at seventh derivative of x. When I differentiate e power x, I get e power x plus e power minus x plus 2 cos x. Derivative of sin x is cos x, derivative of e power minus x is minus e power minus x, minus of minus sign becomes plus sign. Now, when x is 0, I have 1 plus 2, 4, which is non-zero. So, dnf by dx power n is first time non-zero when n is equal to 7. So, least value of n is 7, which is option C. Next question, if x plus y is equal to 4, where x greater than or equal to 0, y greater than or equal to 0, then the maximum value of x cube y is, x plus y is given to be 4, x is given to be greater than or equal to 0, y is given to be greater than or equal to 0, and we want maximum value of x cube y, maximum value of x cube y. So, we can do this question in two ways. One, we can apply AMGM inequality. As x is given to be positive, y is given to be positive, we can go for AMGM inequality. Let me write this as, I need x cube, 3x terms. So, let me write this as x by 3 plus x by 3 plus x by 3, x by 3 plus x by 3 plus x by 3 plus y is given to be 4. So, let me apply AM greater than or equal to GM on these 4 numbers. Applying AM greater than or equal to GM on the numbers x by 3, x by 3, x by 3 and y, their sum divided by 4 will always be greater than or equal to 4th root of x by 3 into x by 3 into x by 3 into y, their product. So, we can say, as we know this number is given to be 4, 4 by 4 is 1, raising to the power 4 on both sides, x cube y by 3 cube 27 is greater than or equal to 1, or x cube y is greater than or equal to 27. So, the maximum value of x cube y will always be 27. X cube y is less than or equal to 27. So, maximum value of x cube y is 27, and that is when y is equal to x by 3. So, answer is option B. Alternately, using calculus, we can do this question. X plus y is given to be 4, x and y are both positive, and we need to find the greatest value of x cube of y. So, let me convert this into a function in terms of single variable. X cube into y is 4 minus x. So, function is f of x is equal to x cube into 4 minus x. Let me plot the graph of this function. For this function, 0 is a repeated root, repeating 3 times, and 4 is another root. This is a polynomial of degree 4 with coefficient of x power 4 negative. So, graph starts coming from minus infinity, becomes 0 for the first time at x equal to 4, comes up. It is a point of inflection at x equal to 0. X equal to 0 is a repeated root, repeating 3 times. So, the curve touches x axis at 0, and that too it has a point of inflection. So, this is the graph of f of x. It has maximum value somewhere here. That is where derivative is equal to 0. So, let us see at which point between 0 and 4 derivative is equal to 0. F dash of x is differentiate 4x cube, it is 12x square minus differentiate x power 4, it is 4x cube. So, f dash x is equal to 0 implies either x equal to 0, that is at the point of inflection, or x is equal to 3, that is at this point. So we have maximum when x is equal to 3 and the maximum value is x cube 27 into 4 minus 3 1, which is 27. So answer is 27. Next question, find the minimum value of x1 minus x2 whole square plus x1 square by 20 minus root over 17 minus x2 into x2 minus 13 whole square, where x1 is any positive real number and x2 belongs to 13 to 17. We need to find the minimum value of x1 minus x2 whole square plus x1 square by 20 minus root over 17 minus x2 into x2 minus 13 whole square. We need to find the minimum value of x1 minus x2 whole square plus x1 square by 20 minus root over 17 minus x2 into x2 minus 13 whole square, where x1 is a positive number and x2 belongs to 13 to 17. That is the main constraint for this. For this to be meaningful, x2 should belong to 13 to 17 and x1 it is given to be a positive real number. Now see, this is in the form of x1 minus x2 whole square plus y1 minus y2 whole square, and looking at that x1 minus x2 whole square plus y1 minus y2 whole square, we recollect distance formula. So if I consider the function y is equal to x square by 20, x1 comma y1 is any point on the curve, y is equal to x square by 20, and consider the curve y is equal to root over 17 minus x into x minus 13, x2 comma y2 is a point on this curve. We want the minimum value of distance between these 2 points. x1 comma y1 is any point on the curve y is equal to x square by 20, and x2 comma y2 is any point on the curve y is equal to root over 17 minus x into x minus 13. We want least value of distance between these 2 curves. Now first curve, we understand it is a parabola, y is equal to x square by 20. Second curve, square it, y square is equal to 17 minus x into x minus 13, or y square plus x minus 17 into x minus 13 is equal to 0. Now this we can identify it as a circle with the diametric ends as 13 comma 0 and 17 comma 0. So center would be midpoint of 13 and 17, 15 comma 0, and radius would be 1 unit, 2 units. 15 comma 0 is center, 17 comma 0 is one diametric end, 13 comma 0 is the another diametric end. This equation can also be written as x minus 15 whole square plus y square is equal to 4. Now we want some point x2 comma y2 on this curve circle and x1 comma y1 on the parabola. We want distance between them to be least, and distance will be least between any 2 curves along their common normal. Distance between any 2 curves will be least along the common normal. So let us find normal to the curve y is equal to x square by 20, which is also normal to the circle, and any normal to the circle will pass through its center 15 comma 0. So we want normal of the curve y is equal to x square by 20, which passes through the point 15 comma 0. For that, let us say any point on this parabola, we assume it as alpha comma y coordinate would be alpha square by 20. Equation of normal at this point passes through alpha square by 20 is y coordinate at that point, alpha is x coordinate at that point. So, y minus y1 is equal to m into x minus x1, where m is minus dx by dy. Minus dx is minus 1 when we differentiate with respect to alpha, dx by d alpha divided by dy by d alpha with a minus sign. Dy by d alpha is 2 alpha by 20 or alpha by 10. 10 goes up, and equation of the normal is y minus alpha square by 20 is equal to minus 10 by alpha into x minus alpha at any point alpha comma alpha square by 20 on the curve y is equal to x square by 20. Now, we need the common normal, that is normal of the parabola passing through 15 comma 0. Substitute 15 comma 0, y coordinate is 0. So, let us make this 0, and x coordinate is 15. So, let us make this 15. Now, look at the equation. We have alpha cube, cancel the minus sign on both sides, alpha cube is equal to 200 into 15 minus alpha. Alpha cube is equal to 200 into 15 minus alpha. So, we need to find root for this equation. Alpha cube is equal to 200 into 15 minus alpha. By inspection, we can find a root. Alpha is equal to, it should end with zeros. So, guess with 10. Alpha equal to 10 is 10 cube 1000. 5 minus 10 is 5. 5 into 200 is also 1000. So, alpha is equal to 10 is a root of this equation. So, point on the curve is alpha, which is 10, comma alpha square, which is 100 by 20, 5. So, we need to find this common difference, distance along the common normal. This distance would be answer for our question. Now, instead, this total distance is distance between the points 15 comma 0 and 10 comma 5, minus, from that we need to separate radius of the circle, which is 2. So, our answer would be distance between the points 10 comma 5 and 15 comma 0 minus radius of the circle, which is 2, and distance between 10 comma 5 and 15 comma 5. 10 minus 15 is 5 square 25 plus 5 square 25 root 50. Root 50 is 5 root 2. 5 root 2 minus radius of the circle, which is 2. So, answer is 5 root 2 minus 2, option A. We want minimum value of square of the distance. We got the distance to be 5 root 2 minus 2. So, square of the distance is 5 root 2 minus 2 whole square, which is option A. Next question. Total number of points of non-differentiability of the function f of x is equal to minimum of 1 comma 1 plus x cube comma x square minus 3x plus 3. We need to find the number of points of non-differentiability of the function. F of x is equal to minimum of 1 comma 1 plus x cube comma x square minus 3x plus 3. Discuss non-differentiability of this function. Let us plot the graph of f of x. F of x is minimum of 1 plus x cube and x square minus 3x plus 3. Among 1 and 1 plus x cube, whenever x is positive, 1 is minimum. We can ignore 1 plus x cube on the right side of origin, and we can ignore 1 in the left side of origin. So, let us draw the graph of 1 on the right side of origin. Constant function parallel to x axis. And to the left side of origin, let us draw the graph of 1 plus x cube. X cube graph will be this way, strictly increasing function, has a point of inflection at 0. When we add 1, the graph rises upwards, and this is how the graph would be, tending to minus infinity as x tends to minus infinity. Then we also need to plot the graph of x square minus 3x plus 3. X square minus 3x plus 3 has least value at x equal to 3 by 2. It's a quadratic, and a quadratic with coefficient of x square positive has least value at x equal to minus b by 2a, that is when x equal to 3 by 2. And that least value would be, substitute 3 by 2, 9 by 4 minus 9 by 2 minus 9 by 4 plus 3. 3 is 12 by 4 minus 9 by 4 is 3 by 4. So, least value of x square minus 3x plus 3 is at 3 by 2, and that value is 3 by 4, which is smaller than 1, and it is a upward parabola. So, this is how the graph would be. Now, we need to identify f of x graph which is minimum of the two. So, which one is below the other, that becomes f of x. So, in this region, the one which is below, erase the one which is up, that is the quadratic. In this region, erase the one which is up, that is x equal to 1, and from this region erase the one which is up, and the one which is below, that is x equal to 1, will be our function. So, this is the graph of f of x. Clearly, we have a point of non-differentiability at this point and this point, and these are the points where the quadratic is equal to 1. This is the line x equal to 1, and this is the graph of the quadratic. So, we have clear non-differentiability at the points where x square minus 3x plus 3 is equal to 1. And let us see at how many points. The question is, find the total number of points, not the points. The total number of points at which the function is non-differentiable, and the number of points at which the function is non-differentiable is 2. So, at 2 points function is not differentiable, and they are the points which are solutions of this equation. So, it is option A. Next question, find the maximum value of root over minus 3 plus 4x minus x square plus 4 whole square plus x minus y whole square, where 1 is less than or equal to x is less than or equal to 3. We need to find the maximum value of x minus 5 whole square plus 4 plus root over minus 3 plus 4x minus x square whole square. It is given that x lies between 1 to 3. That is, for the sake of the domain of this function, x is given to lie between 1 and 3. Now, if we observe this, we can see it in the form x1 minus x2 whole square plus y1 minus y2 whole square, x1 minus x2 whole square plus y1 minus y2 whole square, or we can also write this as root over minus 3 plus 4x minus x square whole square plus 4 whole square, and this 4 can be written as minus of minus 4, minus of minus 4. So, x minus 5 whole square plus y minus minus 4 whole square is nothing but distance between 2 points. One is 5 comma minus 4, x coordinate is 5, y coordinate is minus 4, some point away somewhere here, and a point on the curve y is equal to root over minus 3 plus 4x minus x square. Let us identify this curve. Square on both sides, y square is equal to minus 3 plus 4x minus x square, or x minus 2 whole square plus y square is equal to 1. So, this curve, it is a circle with center 2 comma 0 and radius 1. it's not the entire circle but only upper part of the circle. Y is root over, plus root over. So, y coordinate is positive, it is only upper part of the circle with center 2, 0 and radius 1. Now, we want such a value of x and y for which distance between these 2 points is maximum and least distance or greatest distance between 2 curves. This point is a curve and this semicircle is a curve. The distance between 2 points on these 2 curves will be maximum along the common normal. So, common normal for a point is any line passing through the point, and common normal for a circle is a line passing through the center. So, greatest distance will be this particular distance, which is nothing but radius 1 added to distance between the points 5, -4 and 2, 0. So, we see distance between 2, 0 and 5, -4 under root 3 square plus 4 square 5 plus radius of the circle 1. So, maximum distance between these 2 points is 6. So, answer for this question, which is square of the distance x1 minus x2 whole square plus y1 minus y2 whole square of the distance is 6 square 36. So, answer is 36, which is option B.